So today we are going to see how to solve this question. So here we can see the question on the screen, and the question is find whether these given vectors x1, x2, x3, whether they are linearly dependent. And if they are so, then we also have to express one of these as a linear combination of the other. So we are going to use a matrix method to solve this question. So first of all, I'm going to express all these vectors in the form of the coefficient matrix. So this coefficient matrix we are going to write in this manner. 1, 3, 4, 2, then 1, minus 5, 2, 2, then 2, minus 1, 3, 2. And now what I'm going to do is I am going to use the row reduced echelon form, RREF. Okay, row reduced echelon form. So I'm going to use basically row transformations to convert this to the row echelon form. So if you want to have a recap about row and column transformations, you can refer to the link of the video which is given in the description box. So let us convert this. So we will use these transformations, R2 minus 3 R1, then R3 minus 4 R1, and R4 minus 2 R1. And using these transformations, we are going to get this as 1, 0, 0, 0. Then 1 minus 5. This will, sorry, one sec. So, yeah. So this will be minus 14. Then this is 2. This is minus 7. Then after that, this will be minus 10. This will be minus 5. So minus 4, minus 2. You are advised to, do these arithmetic operations yourself so that it will be better for you. Now, in the next one, we are going to see whether we can reduce this further. So let's just try to, so I think, there is a connection between C minus 14, 10, 4, minus 7, minus 5, 2. And we can do this as R4 plus R3 minus R2. So if we perform this operation, we'll have 1, 0, 0, 1 minus 14 minus 10, 0. And after that, 2 minus 7 minus 5, 0. Okay. Now, let's just check any further transformations, if it's possible to reduce the element which is given over here or over here. Is it possible to reduce it to 0? Maybe one of them, but not both. So the rank in any case will not change. As you know that in RREF form, what is the thing? That the non-zero rows, right? Non-zero rows is equal to the rank. So we are going to now declare the rank of this matrix. So I'll just write this as rank of A is equal to 2. Now, if the rank of this coefficient matrix is less than the number of vectors, which in this case happens to be equal to 3, right? So 2 is less than 3. So therefore, these vectors are linearly dependent. Now, had it been the case that the rank was equal to the number of vectors, then these vectors would have been linearly independent. So let's just look at what is our question. So our question is that you need to find out whether the vectors are linearly dependent. So we just now found out that the answer to this question is yes, they are. And now, if so, express one of these as a linear combination of the other. So that is the second part of this question. So let's go to the second part. Okay, so let me, yeah. So here we'll go to part 2 of this particular question. So what I'm going to do now is I'm going to express one of those vectors, let's say x3, as a linear combination of the other two. So I'll just write this again, a1 x1 plus a2 x2. Right? Okay. Now we will actually write the values of x3, x1, and x2 in this equation. So 2 minus 1, then 3, 2 is equal to a1 times. So this is x1, 1, 3, 4, 2 plus now a2. So x2 is 3 minus 5, 2 and okay. Now we are going to multiply a1 inside to the matrix, and then we are going to add those elements and we are going to have a new matrix. So I write this as a1 plus 3a2. Then we are writing 3a1 minus 5a2. Then 4a1 plus 2a2. Let me just write this again. And here we will have 2a1 plus 2a2. And this is equal to this particular matrix on the left-hand side. Now what we will do is we will form 4 equations and we'll solve for the values of a1 and a2. So here we have a2. So a1 plus 3a2 is equal to 2. Then 3a1 minus 5a2 is equal to minus 1. Then yeah, 4a1 plus 2a2 is equal to 3. Then 2a1 plus 2a2 is equal to 2. Now I'm going to solve this. So from this equation, we can write a1 is equal to 2 minus 3a2. And now what I'm going to do is I'm going to substitute this value of a1 in this equation, right? So once I do this substitution, then what happens? Then we will one by one start getting the values of a1, a2, and then rewrite that in our equation. Okay, fine. So let's continue the process. Okay, so this is where we will substitute. So after substituting over here, what I'll get is 3 times 2 minus 3a2, okay, minus 5a2 is equal to minus 1. And if I just expand this, I'll get minus 14a2 is equal to minus 7, and that will give me a2 is equal to 2. Now I can substitute this value in any of the above equations, and I'll easily be able to find the value of a1. So let me write implies A1 is equal to 2 minus 3 times A2. So I'm putting basically, I'm using this equation now. So 3 times 2. So 2 minus 6. So A1 is equal to minus. So now I've got the values of A1 and A2. So once I've got the values of A1 and A2, now I can just resubstitute in the original equation, right? So this is A1. Now the original equation which we had decided the relationship between the vectors was x3 is equal to A1 x1 plus A2 x2. So this will give me x3 is equal to minus 4x1 plus 2x2. So in this manner, we have solved this question. First, we proved that the given vectors are linearly dependent, right? That is what we had proved. And now we have seen the relationship between the two vectors. Okay, so this is the manner in which this particular question can be solved.